do. So, and what we're going to do, because of what the white paper I just gave you doesn't really lend itself to be glued in very easily, we're going to write some stuff on here, but then you're going to fold the white paper in half eventually and just put like a strip of glue on it and like glue it down there sideways so that you can kind of flip this up and see what you wrote. We're not going to write a whole bunch, but that way you can kind of use this too, because there's really no place to write it on here. So let's just title this Exponential Formulas, because the formulas are already written on there. I just want a quick little assessment here that we know what everything means. So looking at the top of the white paper, because we don't have to rewrite them, you have 4 little formulas written out there, right? Whether it's the capital A or the Y, what does that represent in those formulas? So it's the stuff on the left-hand side of the equal sign. Just in general, like how could you describe what that would be? The results or the amount remaining, whether it's money or bacteria or whatever it is, people, whatever. So we can say amount remaining is a good way to, because to be specific, it's hard to be specific when we don't know what they refer to, because they could refer to a lot of things. So we're just kind of generalizing. That's your end result of basically. So then either the P or the A naught, that little A sub 0 there, what does that represent? What does the P represent in those? Do you know what those formulas are even for? Bless you. The 2 ones with P, that's interest, right? Yes, interest. And then that last one is an exponential that could represent half-life, depending on how we use it, that sort of thing. So the P or the A sub A naught here, this is just your initial amount, what you start with, whether it's money or people or whatever. Yeah, I'll trade you. Okay. We good with that? So that gives us what's on the left, the first thing that's on the right there. And then in the second and third equations, you have an R. What do you think the R stands for? Rate. And then the last one, you have a K. They pretty much represent the same thing. Okay? They're both lowercase. My handwriting's bad. My K's never lowercase. Okay. So it could represent growth, which would be if it's positive, or decay, which would mean it would be negative. Or it could be, depending on if like we're talking about money or something like that, it could be appreciation, which would be a positive rate. So like if I have an interest in something's growing. Or it could be depreciation, which would be negative. So like after you buy something, it starts to depreciate. So the value reduces at some rate. So that R and K are that rate. Both of these, this is some sort of rate. If it's an increase, it's positive. If it's a decrease, it's negative. Okay. Sometimes these formulas are shown with like a plus or minus. I don't know that that's necessary as long as you understand the concept of what's happening with the rate. We good with that? All right, so what does T stand for? Time. So this is just the elapsed time. And this all should be a review. You do this quite a bit in Algebra 2. So. And then in that second equation, is it the second one? Yeah. The second equation, there's an N. Now that's an interest equation, right? So what does the N stand for? Do you remember? Yeah, it has to do with like quarterly or monthly or annually or whatever. Okay, so T represent times in T, and those represent time in years. So N is the number of times compounded in a year. So like if it said, I can't spell year. So if it said it's compound 3 years and it compounds quarterly, something like that, then the T would be 3 and your N would be 4 because it happens 4 times a year. Okay, we good? Does that look familiar? I get a lot of blank stares. I don't know if it's because we're ready for Thanksgiving or we don't remember, so I'm hoping we get it right. Okay. All right. So we all okay with those formulas? Look familiar at least, right? Okay. We're only going to do a couple on this paper because this paper doesn't really relate to the assignment 100%. So I'm actually going to change a few things on here too, but just use these problems since we have them. So we're going to start by looking at number 5. We're going to start really super easy here. And that's the wrong one. There we go. So number 5, it says, given the principal and the annual interest rate, the amount of time for each investment and the type of compounded interest, find the amount at the end of the investment. Okay, so we're going to start with number 5. So I'm looking for the amount, and since it is compounded monthly, right, these are my 2 interest formulas. This one gives me like time in years. What do I use this one for? What kind of compounding? Continuous, the continuous compound. Okay, good. So that means I'm using that second little equation there. My principal is 1,000 times, and then that's 1 plus the rate. It's 10%, but you always have to put your rate in as what? A decimal. So it's 0.1 or 0.10 if you want over what? What would the n be here? 12, because it's monthly, so that's 12 times a year. Close my parentheses, and then it is n times t. So my n again is what? 12, and my t is 4. Okay. So this is just a plug and chug type of equation. Let's go ahead and type that in. I just realized I didn't pull my calculator over here where I could grab it. Oh, and if you didn't grab a calculator, you can come back here and grab one. I'm not going to worry about numbers right now for y'all because we're not going to use them again very much right now. Okay, so I'm going to type in 1,000 times 1 plus, and then I'm going to put this, actually I don't have to put this part in parentheses, but it makes me feel a little bit better so I'm not messing things up. Okay. And then when I do my exponent, that 12 times 4, I either can type in 12 times 4 or I know that's 48. Sometimes those numbers aren't real pretty, so you kind of want to type it in, but I can just take it to the power of 48. That's what I got. Is that what y'all got? Yes. Make sure that that is what you get. And since we're talking money, this is 1489.35. 1489.35. Okay, so everybody okay with that? So we did that one just so that you kind of got the feel for it again, because there aren't any where we're just going to plug in the numbers and get an answer anymore. So that means that I'm going to change number 7 just a little bit. On number 7, I want you to mark out the rate. I want you to mark out the 2 months. Okay, so we know we have a principal of 750. We have a time of 3 years. It is continuous compounding, and we want to end up with, let's see, we want a result of $1,000. I wanted $1,000. And we want to know what would the interest rate be. Well, I was trying not to make it too wordy, but too bad. Interest rate B. Okay, so basically I'm looking for the rate here. If I start with the principal of 750, in 3 years compounding continuously, what interest rate would I need to be able to end up with $1,000? Does that make sense? I could have worded that a whole lot better, but. And then just because we're going to be doing work around here, we can just mark this whole thing out so we can pretend like it's not there. That way we have some room. So I'm going to rewrite, since I can't see it up there, I want to make sure that we are all on the same page. This is continuous compound, so, oh, not y. So A equals, it's the PERT formula, right? P times E to the RT power. So just like anything else we do, we substitute in everything we know. Do we know the resulting amount that we want? Yes, it's 1,000. Right? That's equal to the principal. We know we start with 750 because that's all we got, but we need $1,000 in 3 years. And then E, the R we don't know, right? And the T we do know, which is 3 years. Okay. Everybody with me? So in order to figure out the rates, I'm going to have to use my logs here a little bit, right? So what's the first thing I need to do? Divide by 750. So this is going to give me 1,000 over 750. I can reduce that, but I really don't care because I'm using a calculator, so it's not even worth accidentally doing something wrong. Times e to the 3r power, or r times 3, whatever. So what would I do next? Natural log. So to get rid of the e, I can take the natural log of both sides, right? When I do that, what's the natural log of e to the 3r power? 3r, because the natural log of e is 1, right? So when I take the natural log of e to any power, I'm just left with that exponent. So I get the natural log of 1,000 over 750 equals 3 times r. Everybody with me on that? So to find my rate then, I just divide by 3, so I get the natural log of 1,000 over 750. That's all the natural log there. Divided by 3. If the parentheses stress you out, you don't have to type it in all at once. I can take the natural log of 1,000 divided by 750 and hit enter, and then I can just take that number, I can just do divided by 3. Remember, we don't retype anything, everything has to be exact. So I get this, 0.09589, 0.09589, right, which to 3 decimal places is 0.096, but we write our rates as what? Percentages, so my rate would be what? 9.6%. Everybody okay with that? That's more how you're going to handle these. Like, you have to have the formula. If you understand how to solve a log, which y'all are doing okay on that, you're able to solve them. If you can read a problem, you can substitute your stuff in, then you just got to solve for something in the exponents, you're going to be fine. Okay? We good with all that? Any questions? All right. So now we're going to jump down to number 10, because there's a couple different ways to handle this, and I was struggling yesterday with why do we make things more complicated when we don't need to? And then when I realized the notes didn't really match the homework, it made more sense to me that because there's a couple different ways to handle half-life, and half-life is probably something that you've done in science. I don't know exactly how you have been expected to handle it, but we have that formula up there at the top. I'm going to just rewrite it right here. Y equals a naught times e to the kt power, right? So that's a great formula for half-life type of stuff, or if something's doubling or whatever, if you know what k is, right? But if we know that something is doubling, we don't necessarily need to be so fancy. So we're going to look at this both ways, because you do need to know how to find k, because that's really more what your assignment's going to be like. But again, there's no need to complicate things if it's not necessary. So in order to figure out the answer to, like, find the number of bacteria present after 3 hours, or find the number of bacteria present after 6 hours, then I can figure that out by figuring out k, but it's totally not necessary. If I know that it says the number of bacteria in a petri dish culture doubles every 3 hours, right? So it's going to take 3 hours for it to double. Well, since it's doubling, the base of my exponent is 2, right? And if the base of my exponent is 2, I start with 2,500. So y equals 2,500 times 2 to some power, right? Well, if it's going to double after 3 hours, then my exponent would have to be 1 after 3 hours, right? And if my time is going to be hours, it would have to be like t over 3. So if I substituted in 3, I'd have 2 to the first power, so it would double in 3 hours. Does that make sense? So you can kind of reason through it. I don't have to have anything that has anything to do with E. And that is one way to do it. And if I'm just looking for my result, which we all know that unfortunately we don't always just get to look for the result. That's always the easiest thing to do, but we're always looking for something else. That works. But you have to kind of reason through what your exponent would be. Here, your time represents whatever the time happens to be in hours or whatnot. So we want to figure out what k is. I know we don't have to in this problem, but you're going to have to on the paper, so we're going to pretend like we need to. So instead of this saying find the number of bacteria present after 3 hours, we're going to say find k and write equation. Okay. And we're also going to kind of mark that out so we have room to write. And I may end up writing down, we're not using these problems, so we can just kind of ignore what's going on. So in order for me to find K, I want to know what K is. It says the number of bacteria in a Petri dish doubles every 3 hours. All right, so we start with how many? 2,500? That's your A naught, right? So we're going to start with 2,500. And then e to the k times 3. It takes 3 hours for it to double. And this would be 5,000. Right? Does that make sense? Like it's doubling there. Everybody with me where everything came from? Right? It's doubling. That's how I knew what to put here. I want to know what is k when it gets doubled. Well, this is what I start with. This is what will be doubled, right? And it takes 3 hours. That's how long it takes to double. Everybody with me? So now I'm going to try and figure out what k is. So I'm going to divide both sides by 2,500. So what's 5,000 divided by 2,500? 2. So now I just want you to look at what's happening here. I don't want to start here because I don't know how many of these you've done like this. But we've got 2 equals e to the k times 3. So I didn't even have to know what my initial stuff was. When it doubles and you know the time, that's really all you have to do. Doubling, so it's a 2 equals e to the k, and then it takes 3 hours. And then we can figure out what k is. And then I'm going to leave room over here for this one. I want to work down here, so you can just ignore this question. So I need to get k by itself. So what am I going to do? Natural log. So I'm going to take the natural log of 2. That equals the natural log of e to the k times 3 power. So what happens over here? What am I left with? Just k times 3, right? Natural log of e to this exponent just gives me the natural log of 2 equals k times 3. So that means that k equals the natural log of 2 over 3. So there's my k. It's not real pretty, but it's not, I mean, we can get a decimal and store it if it makes, when you need to do it, but that's what my k value is, to leave it exact. Everybody with me on how we got that and why? So now to rewrite my equation, looking like this, that means that I get y equals 2,500 times e to the k, which is the natural log of 2 over 3, times t, whatever t is when we're using it. You can represent k as a decimal as long as you use the stored one. It's fine. Everybody with me on how to get that? So now we're going to take this formula and answer B. Okay, it says find the number of bacteria present after 6 hours. So that means t becomes 6 hours, right? On the interest ones, t is years no matter what. But with half-life formulas, it's whatever it is, and it's hours, and it's fine. So I get y equals 2,500 times e to the natural log of 2 divided by 3 times what? 6 hours. Okay. Now, is this going to simplify a little bit? Like since you're using a calculator, you don't even have to simplify it, but sometimes it helps. If you want to type this in and store it and then use your stored number, that works too. But the natural log of 2 divided by 3 times 6 is just what? Natural log of, 2 times the natural log of 2. So it's 2,500 e times 2 to the natural log, or e to the 2 times natural log of 2. Let's type that in. We get 2,500 times e to the 2 natural log of 2 power. You get 10,000. Now, look what would happen here. If I had used this, your t is 6 hours, so it'd get 6 hours over 3, which would be 2 squared, which is 4, and then 4 times 2,500 is 10,000. All right? So this is one of those cases where it's not necessary to find k and make it more complicated, but it's possible, and there's reasons that that's important, because again, we're not doing it directly like this. If it's not always going to be doubling and halving. So if you're thinking, why didn't I just do it this way? I totally, in this particular case, I would suggest doing it this way. But I'm trying to do an example of where you can find, where you have to find K, because you're going to have to do that on your worksheet. Does that make sense to you? Okay. Questions? We all good? All right. Any questions about any of it? Don't be afraid of it. Read what it says, substitute in what you know, and make sure like you're actually substituting it in and writing it down. Then you just solve the log like you've been doing. That's the only difference between what we've been doing. Okay? We good? I just wanted to make sure you knew the parts of the formulas and how to handle those.